Hello boys and girls, this is Mr. Kizik, and in this video here we're going to be learning about how to factor trinomials when it's in the form of x squared plus bx plus c. So a little review, let's factor out, or not factor out, let's FOIL these binomials here. So we're going to do x times x squared, x times 5, 5x. 1 times x, 1x, 1 times 5, 5. Combine my terms, and I have x squared plus 6x plus 5. And we'll just do another one just for kicks here. M times m is m squared. M times 6, 6m. Negative 4 times m is negative 4m. And negative 4 times 6 is negative 24. Combine like terms, and I have m squared plus 2m minus 24. And the last one's the same concept, but we won't worry about that one. So, basically what it says here, what we got in the right-hand column, trinomials that are like these, in other words, where there's always a 1 in front of the square term, we can factor back into the products of binomials by doing this simple little trick. The simple little trick is this. You must find two integers that multiply to c and add to b. Right? So again, you just need multiplication, know your multiplication tables, and then just know how to add. Now, if I look at this one example here, x squared plus 7x plus 12. So you're going to think of what two numbers have a product of 12, and those same two numbers add to 7. Well, we know something like, for example, 6 and 2. They multiply to 12, but is there any way that they could add to 7? The answer is no. So I have to think of two numbers that multiply to positive 12 and add to positive 7. And the two numbers are 4 and 3. So to write the binomials, well, you're just going to write the binomials using these integers. So x, or whatever variable you have, plus 4, x plus 3. And what you could do is you could check yourself by just distributing. X times x, x squared. X times 3, 3x. 4 times x, 4x. 4 times 3, 12. And do I get back to the same result? I do. So I know I have the correct answer. So as you can see here, there's different sets. In other words, different ways we can have a problem here. So like, for example, if I have plus plus, which is usually the easiest one here, I'm just going to think of what two numbers multiply to 20. So what two numbers multiply to 20, and those same two numbers add to give you 9. So first thing you want to do is just think of numbers that multiply to 20. All right, 1 and 20. That doesn't work. 2 and 10. Nope, can't add them to give me 9. 4 and 5. Can they add up to 9? And yeah, 4 and 5. So my final answer is n plus 4, n plus 5. And there you go. So look at another one. So for number 3, we'll look at what two numbers multiply to give you 24, and those same two numbers add to give you 10. Well, hopefully you found out or figured out that 6 and 4 are those two numbers. So this is going to be a plus 6, a plus 4. All right, let's look at the second set. So the difference here is that the c term is negative. So you're figuring out what two numbers multiply to give you negative 18, and those same two numbers add to give you 3. Now, one thing you want to think about here is, in order to multiply to a negative number, what do one of the numbers have to be? That's right, one of the numbers has to be negative. So when you're thinking about this, so think of, again, numbers that multiply 18. Let's just say, for example, 9 and 2. That means one of them has to be negative. Is there any way I can have one of the numbers be negative, like I said, 9 and 2, so that they can add to positive 3? And the answer is no. So when I think about it, positive 6 and negative 3 is my answer here, because 6 times negative 3 is negative 18, and 6 plus negative 3 is positive 3. So n plus 6, n minus 3. Another way to think about it is when you got something like this, you're basically saying what two numbers, when I subtract, give me my b term. So if I look here for number 7, again, what two numbers multiply to give me negative 6, and those same two numbers add to give me 1? Well, 3 and 2 work. Now, which one has to be negative? That's correct. The 2 has to be negative. So my final answer is going to be g plus 3, g minus 2. Right? Let's look at the next set. Same concept again, except now both minus minus. So you're basically saying what two numbers multiply give me negative 3, and those same two numbers add to give me negative 2. Well, the only two numbers that multiply 3 are 3 and 1. So one of them has to be negative. Which one has to be negative so when I add them together, I get negative 2? It would be negative 3, because negative 3 plus 1 is negative 2. So a minus 3, a plus 1. Number 11, what two numbers multiply give me negative 63, and those same two numbers add to give me negative 2? Let's see, it would be 9 and 7. Which one has to be negative? The 9 has to be negative, because negative 9 plus 7 is negative 2. So b minus 9, b plus 7. All right, the last set here, again, you're finding out what two numbers multiply to give me positive 24, and those same two numbers add to give me negative 11. Now, in this case here, what possible combinations can I only have here? In order to multiply the two numbers to be positive, and those same two numbers have to be a negative, the only way that could happen is if both numbers are negative. So just think of what two numbers have to multiply to give me positive 24, and add to negative 11, knowing they both have to be negative. That would be negative 8 and negative 3. So x minus 8, x minus 3. And then the last one to say here, what two numbers multiply to give me positive 72, and those same two numbers add to give you negative 17. And that would be negative 9 and negative 8. Y minus 9, y minus 8. So the hardest thing here is to just figure out your multiplication table. So if you don't know your multiplication tables, I would suggest reviewing that for yourself, because it'll make life a whole lot easier. So before you move on here, I just want you to try 17, 19, 21, pause the video, and then unpause it to check the answers. All right. Welcome back. So here are the answers for 17, 19, and 21. For 17, you should have a plus 8, a minus 2. For number 19, you should have, not what I was thinking of here, y plus, both are plus here, 8, y plus 5. And then for the last one, you should have n minus 6 and n plus 5. The other thing I forgot to mention here is that it does not matter the order. In other words, for like number 21 here, if you had n plus 5 and n minus 6, that's still the right answer. All right, so that order doesn't matter, but yes, 6 has to be negative and 5 has to be positive. All right, the next part here is examples with a GCF. Remember what I talked about in the last couple of videos actually. The first thing you want to do before you do any factoring is to see, is there a GCF? And then see, can I go any further? So if I look at 23, is there a GCF? Well, yes, the GCF is 4. What's left over? k squared plus 3k plus 2. And now I would do what two numbers multiply to give me 2, and those same two numbers add to give you 3. Well, the only possibility is 2 and 1. So my final answer would be just 4, k plus 2, k plus 1. Let's look at 25. What's the greatest common factor here? Would be 3. What's left over? Y squared minus 5y plus 4. Same thing, what two numbers multiply to give me positive 4, and those same two numbers add to give me negative 5? That would be negative 4 and negative 1. So 3 times y minus 4, y minus 1. And actually, the next one I want to look at here is number 28. So you can do number 28. You can do all these. So with number 28, is there a greatest common factor? And there is. The greatest common factor for the number portion at least is 5. And what about the variable? Well, there's an x in 2 of the 3 terms, so that doesn't work here. But there's a y in each one. So I can factor out y, and what's left over? X squared minus 3x minus, and then 140 divided by 5 is going to be, is that right, 28? Right, 10, 4, yeah, 28. So now, once we get to this part, we're going to see what two numbers multiply to give me negative 28, and those same two numbers add to give you negative 3. Hopefully you said it is going to be negative 7 and positive 4. So my final answer is going to be 5y, x minus 7, x plus 4. And that, ladies and gentlemen, is how you factor trinomials when the number in front of the x squared term is 1. So for your homework, what I would like you to do is I would like you to do all the odd problems here. Again, if you have any questions or concerns, please feel free to get in contact with me and message me.